Across the globe, the need to replace and expand sewer and clean water systems presents vast opportunity. Many developed nations face aging systems long past their useful life. Stressed by population growth and sprawling expansion, costly reactive maintenance and contamination of the surrounding environment is common. In some developing countries, dense urban populations lack the sanitary sewer and clean water infrastructure vital to maintaining basic health standards. And yet, the current state of the global sewer and water systems is only a part of the challenge. A growing number of projects are required to be placed precisely on grade. With traditional installation methods, this work is often viewed to be tedious, labor-intensive, and expensive. Vermeer, a leading developer of trenchless technology, now offers a solution to help meet these widespread issues head-on. The new Axis guided boring system is a pit-launched installation method aimed to achieve pinpoint on-grade accuracy while eliminating some of the difficult steps associated with other installation techniques. A wide range of product pipe, sizing specifications, and other job site requirements can be met with the versatile capabilities of the Vermeer Axis guided boring system. Now, let's learn more about how the Axis guided boring system works. The system is comprised of four main components: the power unit, rack, vacuum pump, and vacuum tank. The power unit contains the engine and hydraulic pumps and connects to the rack to power thrust and pullback of the drill stem. The rack includes the thrust pullback carriage assembly and gearbox. As the thrust pullback carriage assembly moves up the rack, the gearbox simultaneously provides rotation to the cutter bit at the front of the drill head. As the drill stem cuts its way through the soil, the displaced material is simultaneously removed by a high-power vacuum system. Spoil is then diverted to a vacuum storage tank. Let's take a closer look at how the whole Axis-guided boring system works together. Because of the flexibility of the four major components, various setup configurations can be used to adjust the machine's footprint based on job site and transport characteristics. For instance, in an urban job site, the Axis-guided boring system can be set up in one lane of traffic for minimal disruption. Although projects greatly vary, our example consists of a 300-foot, 91-meter bore for a gravity sewer installation. First, two pits are dug at each end of the bore. The first will serve as the launch pit, the other will be the exit pit. The pipe laser is then set in the launch pit at the grade and depth the project requires. Next, the leveling frame is set. And then the rack assembly is lowered into the pit and positioned. The drill head is next. Contained within the drill head is a camera, which is connected to a display on the directional control station. With the camera viewing the laser beam on the target, the operator can accurately monitor the target grade and make adjustments if the drill head moves off course. Keeping the laser dot centered within crosshairs indicates the drill head is on course with the target grade. At the front of the drill head, the cutter bit rotates to cut through the soil. As described earlier, the displaced soil is vacuumed out through the drill head and subsequent drill stem to the vacuum storage tank. Note that only the cutting bit and center drive shaft rotate as the drill stem travels through the bore. The outer section of the stem remains stationary as it is pushed through the hole opened by the cutting bit. After the drill head is bored in, it is uncoupled from the carriage assembly. The carriage assembly retracts to its most rear position and is now ready for the first section of drill stem. Let's take a closer look at the drill stem. The area outlined in green is the site channel for the pipe laser. The lower hollow section, marked in yellow, is the vacuum channel for the displaced soil. In the center of the drill stem is the connection for the drive shaft, which delivers rotation to the cutting bit on the drill head through the entire drill stem. Now let's turn back to the project. The drill stem is then coupled to the carriage assembly and to the rear portion of the drill head. Rotation and thrust from the carriage assembly resumes as the first drill stem is pushed through the hole. This process is repeated with numerous sections of drill stem until it reaches the exit pit. Now it's time to install the product pipe. Based on the versatility of the Axis-guided boring system, many types of product pipe can be installed as the project requires. Depending on the job site, products such as clay or steel pipe, PE or PVC can be installed by one of two principal methods. The first method, known as pipe jacking, requires rigid constructed product pipe in segments, such as clay or steel pipe. After the drill stem reaches the exit pit, the drill stem sections are substituted for product pipe segments in the launch pit. In a similar fashion, the carriage assembly thrusts forward, pushing the product pipe segment through the bore. In the exit pit, as the drill stem is pushed through, segments are hoisted out of the pit. This continues until the final drill stem reaches the exit pit and the installed product pipe now lines the bore. If the job site layout allows, it may be possible to utilize a second method for installing the product pipe, which is exclusive to the axis-guided boring system. When the drill head reaches the exit pit, the drill head is removed and the end of the product pipe is attached to the remaining drill stem. It's also possible to attach a reamer to the end of the puller head, increasing the diameter of the bore to install product pipe larger than the diameter of the pilot bore. Back in the launch pit, the carriage assembly retracts, pulling the drill stem and product pipe back through the bore. When the carriage reaches its fully retracted position, the drill stem is uncoupled and hoisted out of the launch pit. The carriage returns to its most forward position, couples with the next section of drill stem, and repeats the process, pulling towards the launch pit until all drill stem has been removed and product pipe now lines the bore. At this point, the project is now complete. You have now seen the basics of how the Vermeer Axis guided boring system works. A simplistic design, pinpoint accuracy, and an environmentally friendly approach make the Axis system a viable alternative to current water and sewer installation methods. To learn more about the Axis system, contact Vermeer today.